everybody. Good morning. I'm Marc Hartmayer, and I'm working as a software engineer at IBM. It's a pleasure for me to be here today. And in this presentation, I will talk about testing nested guests and nested virtualizations. Trademarks, more trademarks. Okay. First, I will explain what is nested virtualization. Then I will discuss existing frameworks for testing nested virtualization. After that, I will present a short demo for an alternative approach by using self-replicating programs. And then I will explain the technical details of this approach. And lastly, I will give a short outlook what else could be done. So first, what is nested virtualization? The main idea here is to simply turn a guest into a host or a new hypervisor. Use cases are development, testing, production, training, whatever. In this presentation, I will use the terminology L0 is the bare metal host running KVM. L1 is the VM running on L0, acting as a hypervisor. L2 is a VM running on L1 called nested guest, and so on. I've tried that on S390 up to level 7, so there's also L5, L6, and so on. On what is required for nested virtualization on S390X? First, you have to need at least a kernel greater than 48. Then you have to enable kvm.nested by the kernel command line parameter, and you have to enable the CPU host model. And for that, you need at least QEMU greater equal than 2.9. On S390X, we support multi-level nesting support, and as I have told you already, I've tried that up to level 6, 7, I think. And it will get slower the more levels you have. It's hardware assisted on S390X via SI, and the migration works even between different levels, so you can migrate from level 4 guest to a level 1 guest, and so on. We support migration of a level 1 guest, for example, even if our level 2 guest is running. And on S390, as you can see on the right side, we have even another level of virtualization, but this is just in detail because our partitions are already virtualized. So now we will come to the topic, what is available to test nested virtualization. So I've looked what is available explicitly in the scope of my test approach to test the whole stack. So I mean, I would like to test QEMU, KVM, and if possible, libvirt. And this Avocado VT, this has really many, it has a big functionality, it's a huge framework and so on. It has many APIs that you can use. And there are test provider, for example, for libvirt, and there is a test provider for QEMU. And there's a nested test case described. Then there's Avocado QEMU, the acceptance test of QEMU. As far as I know, there's no nested virtualization test case right now. Then there are the KVM unit tests. There are nested virtualization test cases for VMX, but not for S390 right now. Then there's libvirt TCK. There's no nested virtualization test. And then there's a Linux virtualization test, but this is legacy only because Avocado VT is the successor of that. And there's a super nested test case. This is more a little test to show how much level can we get or can we achieve. So I've looked at these frameworks, and Avocado VT seems to be the most evolved framework to write test cases that I would like to write. So I've looked into more detail for Avocado VT, and I hope you can see that on the right side. There's an example slide from the presentation of last year's presentation, the functional test beast. And if you can read it, the interaction with the host is done by using Python, but the interaction with the guest is actually done by using bash via SSH. So the first question that comes up to my mind is, why do we use different levels, different language for the same semantic thing? So for nested virtualization, it would be good to simply reuse our code that we have already in the host in the guest, what is the new host. So wouldn't it be great if we can simply reuse our host code in the nested guest, the new host? Then it would be really hard to debug if there's some failure inside of the guest, if you're using Avocado VT for that. Then, for example, for common tasks like a hot plug, unplug of device, there are workarounds used, such like they are using sleeps, they are using busy loops for polling, or they're using coarse-grained commands like udef-admin settle, so it will simply wait until all udef events are handled, or it will timeout. And there are different semantics. For example, they're using popen sometimes in the host to start a process. And this has a different semantic than, for example, session.command, which uses SSH client in the background. So the exit codes will be transformed and so on. And it's hard to, what's about the error handling, stack traces, and so on. So my main idea was, use your host code in the guest. And first, I will start with the demo. This is an example test case. So I have implemented it in our internal test framework. That's similar to Avocado VT, so it conforms to Python convention. Everything is a Python unit test and so on. And it uses configuration over convention over configuration. And for example, if you define the class attribute domain names, and define here test1, then it will be ensured that you can access a test1 domain, a guest defined in libvirt with the name test1. You can access it with the guest, self.guest. This is an actual virt domain manager. So you can access this guest, it's defined and it's started, and you have an SSH communication channel to it. So what we can do here is now we can simply call a Python function, in this case, check output of the standard library of Python, and we can call it inside of the guest context. So the argument I'm passing here is hostname, then I will get the standard out of this, and in this case, this should be QEMU S390X. But we could also simply reuse the Python function getHostname of the socket module and call this directly in the guest. So I will show you now a test case testing the nested virtualization functionality and define nested guest up to level n, whatever you want to. Okay, I have to switch. Okay, can you read it? Okay. So what I'm doing here, first I'm saying, okay, domain names should be empty. So there will be no domain name defined and started by default. So I'm using 9PFS for the pass-through of the image that I'm using for my guests and for my new guests and so on, for my nested guests. So I have a simple loop. In this case, I'm starting a level 3 guest up to level 3, but you can increase it whatever you would like to. Then I'm preparing the domain. We have something like the Python object to XML mapper for this. So we will get here an XML builder with this memory size and this count of vCPUs. Then we have to enable the KVM nested support by adding this to the kernel command line. Then I'm creating a file system XML builder for the 9PFS. I append this. After that, I'm using the virt domain manager object, guests, and say, hey, please define this in the guest context. And after that, I will start it. Then I have to mount the 9PFS directory inside of the guest, set the name to test_nested, and now should be the virt domain manager, the domain manager of the guest. And then I will continue simply with the loop. That's all. If I would like to pass through, for example, a SCSI device, I can simply do this. In this case, I'm loading a SCSI debug module, get the host, bus, and target, the addresses of this device, add a hostdef XML builder, which I'm defining using libvirt, and then I'm simply adding it. And that's all. Now I can run this. Okay, well, what I have to say here, I have inserted a failure here, so it will stop right there, and I can debug. Okay, it starts level 1 guest, level 2 guest, level 3 guest, it needs some more time. Only some. So it will be get slower. Some seconds. No, it will. Okay. Now we are in PDB, and we will see here the failure message break here. And we will also get SSH command line to connect to this guest. For example, to connect to the test nested guest case, I can use simply this command line. If I'm calling wash list, I'm seeing, hey, here is guest running. So, okay. And if I'm using SCSI here, okay, oops. Oh, I haven't saved it. Otherwise it would work. Okay, so I will continue. Okay, the current state of this code is prototype only. But what I am using is Matryoshkas, and here I will quote David Wilson, this is the maintainer of this project. Make a child's play to run Python code on remote machines. So it's basically a Python library for writing distributed self-replicated programs, has support for Python 2 greater equal than 2.4, required a Python interpreter in the guest, and an SSH client must be installed. And it has 0 Python dependencies, so it uses only a standard library. How does it work? First, it spins up and hooks up a remote Python interpreter, for example, via SSH, and this forms a new context. Then you can call functions inside of this context, and for that it uses marshalling, and for that it uses the Python module pickle. What's really great here is it resolves Python dependencies in remote context transparently. So for example, on the right side, you can see 6 example usage of this library, and it established here a host 1 context to the first host. Then it established a host 2 context by using host 1 context as an SSH hop transparently. And then you can call the psutil function CPU count, even if it's not installed in the host 2 context. So it will be resolved transparently by Matryoshkas for free. It forwards standard I/O to the local host and also the logs done by the logging package. And it supports asynchronous calls. But Matryoshkas is not enough, because if you're looking at the right side, how we would look up a domain by using libvirt Python. So we are calling in the guest1 context the function lookup, and it will import a libvirt Python module, try to establish the libvirt connection, and then it will try to look up the domain. And then it will try to return it. But what we would actually like to have to start the domain in the guest context, because Matryoshkas would try to transfer the actual value, and we are not interested at the actual value, but we would like to start the guest in the guest1 context. So we should handle this, and of course, as soon as the domain is returned, there will be no reference to it in the guest1 context, and we have to ensure that it's still alive and we can use it. So the first idea was, hey, we could do this by remote invocation via proxy objects. So instead of returning the actual value, we return simple proxy objects and methods for everything, and this can even be used for function calls. Then we have to register trusted classes, because unpickling untrusted data is not secure. And I have introduced a special dunder method named value for receiving the actual object. So if we are really interested in the actual value, we can still receive it by using the method __ value. And we can enforce the unpickling of untrusted data or of trust data that we can enforce the unpickling of data by using the keyword trust. Then we have to connect the Python object lifecycles. So as long as the proxy object is alive, the revert object must not be garbage collected. And this leads to some kinds of transitive proxy object chains. Good, now we come to the conclusions. So first, guest can run Python host code transparently. This should lead to less duplicated code in different languages. Then we can reuse Python package like pyudev. And the redirection of standard I/O and logging in the guest is for free. And this should minimize the usage of shell commands. But there are also some limitations. For example, native dependencies are not copied automatically. For example, the libvirt shared object. So you have to prepare that or copy it by yourself. And the Python interpreter must be available in the guest, and there's an overhead caused by the Python interpreter start. But luckily, this is only needed once. And there's some pickling limitation because Lambda functions, for example, are not pickable, but you can use another pickle module like Bill for that. Okay, so let me summarize that. There's still much to do. The test approaches for nested virtualization already exist, but this new approach allows the interaction of the host, guest, and guest using Python. You can recursive reuse of host codes in guest, and it allows you an easy management of nested guests. What's next? First, we have to finish our implementation, upstreaming changes to Matryoshkas, make it easier to debug, implement remote Python debugger, for example. That should be possible. And maybe we could integrate our framework tests into Avocado VT. Because as you can see on the right side, Avocado VT has a huge utilities API that we can simply reuse with this new approach. So thank you for your attention. Questions?
Hi. This looks nice, and I would like to ask how you think we could reuse this. We can work together to also reuse this in Avocado QEMU. It would be interesting to make this available for the tests we have in the QEMU tree for testing nested virt using in the QEMU test case we have. And how do you think we could work together? Do you think you will publish as a separate module, or should we just merge these inside the QEMU Python modules we have? What are your thoughts on that?
For Avocado VT or Avocado QEMU?
Avocado QEMU. Because QEMU? Avocado QEMU is inside the QEMU tree, and it's run as part of the QEMU test cases.
It should be really easy, I think, because I will talk with the maintainer of Matryoshkas to upstream some things into Matryoshkas, and then you'll simply need to use Matryoshkas inside of Avocado QEMU, and then you can use it. Yeah. Maybe we can also have some objects. You have already a QEMU object and something like that, so we have to adapt this, but it should be easily to be done.
Are you using Avocado VT? Because if you don't have specific reasons to do that on Avocado VT, I would suggest try to include that as part of Avocado QEMU, probably.
Yeah, that should be also fine. That should be no problem.
Okay, thank you.
Any other questions? It looks like no, so thank you.